Hello class, good morning. How are you all? How did you solve assignment number 1? Was it easy or difficult? And no one of you asked me any question. I was waiting for your small queries. Okay class, now today we are going to start assignment number 2 from chapter number 1. And the topic on which this worksheet is based is physical states of matter. As you all must have read the properties of the three physical states of matter: solid, liquid and gas. And you must have understood that why particles go in different physical state. What are their relative positions? What are their relative kinetic energy content, and what should be the distance between these particles when they are found in different physical states. So after commanding all these properties, we begin with the MCQ discussion. MCQ number 1 is, which material has the highest melting point? You know, the materials around us or the substances which are found naturally have different combinations or different types by means of its bonding. And the substances which have very strong binding forces in them, such as ionic compounds, such as metals, they are mostly found in solid state. And the other way of bonding is covalent bonding, in which non-metals undergo the formation of the compounds by making covalent bonds in them. And when we study their physical states, mostly they are either in the liquid state or in gaseous state. So we see among these 4 options, one is ammonia. Ammonia means a gas of non-metals, nitrogen and hydrogen. Methane, a compound, an organic compound, consists of carbon and hydrogen, again the non-metals. Water, a molecular compound which is found in liquid states having no ionic character or covalent bonds in them. The only option is sodium chloride, which is made up of oppositely charged ions. You know, the sodium is a positive ion and chloride is a negative ion. Due to their strongest bonding, strongest force of attraction between the elements, between the ions, sodium chloride has the highest melting point. So we see the second one, in which pair each substance a mixture. You know, mixture is a substance in which compounds or elements have no fixed ratio and they are just physically combined. They have no chemical bonding or combination in it. So we see the A option is air and water. Air is a mixture of gases, but water is a compound of carbon, hydrogen and oxygen in a fixed ratio by mass. When we see lime water and water, again the lime water is a mixture of calcium hydroxide and water is a compound. Option C, quicklime, calcium oxide, it's a compound, and again lime water is a mixture. But when we see option number D, seawater is a mixture of so many minerals in water, and air is a mixture of gases. So the choice is yours. For MCQ number 3, which states that what can be deduced about 2 gases that have the same relative molecular mass or molar mass? Option A, they have the same boiling point. We cannot predict anything because every compound has its own unique constant or fixed melting and boiling points. They can be their characteristic. Option B, they have the same number of atoms in one molecule. Yes, it can be. Option C, they have the same rate of diffusions at room temperature and pressure, means their mixing rate is same. They have the same solubility in water at room temperature. So the most closest option, which seems right to me, is they have the same rate of diffusion at room temperature. You know what diffusion is and on what factors diffusion depends. It's only the molar mass. For MCQ number 4, which row correctly identifies the gas? We see the identification of a gas is a chemical test which proceeds with some newness, means maybe some color gas is produced, maybe bubbles are seen, maybe the color is changed, or maybe some solid is produced. So when we see out of these 4 options, just see which option is proceeding with a physical change, maybe a changing color, or maybe formation of some solid, or maybe formation of some color gas. So there must be some chemical reaction. So select the option which is best. Now MCQ number 5, compound Z is made from element X and Y, means when element X combines with element Y, a chemical reaction happens and Z is formed, right? And now the very strong evidence for compound Z, that it is a good conductor of electricity when molten but not when solid. So the idea clicks my mind that ionic compounds are those substances which can conduct electricity very well, but only when they are in their solutions or only when they are molten. So we see what are the possible options. Which statement is correct? It's saying that A, compound Z has a strong force of attraction between electrons and positive ions. No. It's not electron. Compound Z has a strong forces of attraction between negative ions and positive ions. Yeah, it seems sensible because the negative ions are bonded to positive ions in formation of ionic compounds, not the electrons. C, element X and Y are both metals. No, it cannot be. Ionic compounds are formed when metals are bonded to non-metals. Similarly, option C and D are not possible. So what should be the right one? I have given enough clue about it. Now when we see the theory section, the first question is explain the heating curve of naphthalene. Okay. In your textbook on page number 10, there is a cooling curve of naphthalene. So you have to make the heating curve, means the effect of rising temperature on the physical state of the naphthalene. So you have to make it, you have to reverse this cooling curve to get the heating curve of naphthalene. Now the reasoning part of this theory section is, how does the temperature of a solid change when it melts? What changes of states are called as reversible changes? So you have to see that the changes become reversible, means it reoccur itself. So why these changes are called as reversible? They may be happening again and again, and they may be reversed again. So the question is, how does the temperature of a solid change when it melts? You have to study this heating curve very deeply. Discuss the kinetic energy of particles in solid, liquids and gases, and what is the role of intramolecular forces of attraction in the boiling point of the liquid. So you have to apply the kinetic theory to understand the forces of attraction between solid particles, liquid particles and gaseous particles. And what is the role of intramolecular forces? You see, By studying that chart which I sent you in my video clip, you can sum up all these properties, microscopic properties, to predict the physical states. And what is the effect of intermolecular forces of attraction on the boiling points of the liquid? Obviously, when the forces of attractions are very stronger, then a liquid needs much amount of energy to overcome or to break these binding forces and to start boil up or to start escaping from liquid to gaseous state. So you just read the topic, watch the video, then bring out your pens and papers and start writing their answers. Okay, class? If there is anything left of discussion, you can ask me, you can send me your inquiry. I will be satisfying your questions willingly, and just try to do your work on time. Till then, I will come tomorrow again with the next video, with the next worksheet. Thank you, class. Take care. God bless you.